Our objective is to create an automated production system that harnesses the power of industrial 4.0 technologies. Our project harmoniously combines an electrical process control station and the thermal process control station, each operating independently but communicating seamlessly through an empty cell. This synergy ensures a streamlined, efficient production process that optimizes resource utilization and enhances the quality of our product. To give the operator precise control over the system, we have integrated a SCADA dashboard. This intuitive interface facilitates real-time monitoring, data collection, and operational oversight. Additionally, we have established a customer website for them to order the product. Our ultimate goal is to lead the industry into the future, embracing the tenets of Industrial 4.0, automation, data-driven decision-making, and interconnectedness. This project represents our commitment to innovation and progress as we work towards a more efficient, connected, and suitable future in the realm of industrial production.
In order to start production, we first have to receive an order from the clients. So the clients can order the bleach via our website. The client has to fill in their details first, and the amount of bleach they need, and submit the form. We then process the form and start the bleach production.
Yeah, so this is the analytical process station, whereby we have a submersible water pump that will be used to start the sequence. On the SCADA, the operator can start the sequence where we pump in water that will be used to distill the concentrated calcium chloride solution that's added in to manufacture the bleach. We have a pH sensor that's going to monitor the regulation of the pH level, and once the system has reached its required set point and the bleach has been manufactured or processed, it will be transferred into the thermal station for cooling. Considering the amount of bleach that has been ordered on the system, the operator can come to the SCADA dashboard and be able to start the sequence. So on the SCADA dashboard, we have the two stations. The processing station is the analytical process control, and the cooling is the thermal, where one is able to visualize it and start the sequence. So on here, one can start the input, and the process starts with the input pump on. And as you can see, first the liquid water used for distilling the hypochlorite solution is pumped in the reactor tank. So once the pump has pumped in the required solution, we have an ultrasonic sensor that will be used to monitor the level and start the sequence and the regulation of the THP control. So the circle starts here. So the pump starts circulating based on our PID that we've implemented to regulate the amount of pH, whereby we are pumping in the concentrated calcium hypochlorite solution into the distilled water to reduce the concentration up to the required set point. The system will stop circulating once the required range of set point has been reached. As you can see, the pH has changed. Hence, the next sequence will be the transferring of the solution to the thermal station. Once the set point has been reached, the circulation turns on and the transfer of the solution starts moving into the thermal station. So once the transfer of bleach is done from the analytical station, the thermal station is run to begin the cooling of the bleach. So the bleach will circulate through a centrifugal pump running through a chiller, which will maintain the temperature of the bleach at a temperature between a range of 18 to 20 degrees Celsius. and that will finalize the production of the entire bleach.
So this is the code for the analytical station that we wrote. On the main OB, on the first network, we have called the pH sensor, where I normalize and scale the value from the pH sensor. On the second network, we have the whole process for bleach processing. So it starts with first network, where we pump in the distilled water and monitor its level. On the next sequence, we open the inlet and outlet solenoid of the reactor tank, which we have filled with the water, and turn on the circulation pump to circulate the distilled water. At that time, we call the peristaltic pump, which we are controlling its speed with a PID we implemented. Here's the logic. So the essence of the peristaltic pump is to pump in the concentrated calcium hypochlorite solution in order to monitor, to reduce the concentration and regulate it to a pH of around 9 to 11. So once the required set point is reached, we stop the circulation and start the transferring of the bleach into the thermal station. On this network, I receive information from the PLC that the transfer has been completed, and this is used to stop the transfer, and we reset for the next batch. And for safety reasons, we have a stop function that's used to stop the process whenever the operator presses either the stop or emergency buttons. So on the thermal station, on the main OB, on the first network, I'm calling in the temperature transmitter, which monitors the temperature of the bleach. And on the second network is where the cooling actually happens. So on the first network, we send information to the PLC on the analytical station to say the level of the process tank as once it's been reached or filled, to stop the transfer of the bleach. Then we turn on the centrifugal pump that circulates the bleach to the chiller, which we also turn on. And we have a hot centrifugal pump that circulates warm water, which we regulate the flow rate of the warm water in case the temperature of the bleach goes below the required one which we want. So when the temperature is either below 16, the pH will be called, and once that's done, we'll stop the circulation. To indicate, this network indicates the system is finished. So this is the PID. Whenever the temperature of the is below 18, the PID will be implemented. We have a set point input transmitter, and this regulates the flow rate of the temperature transmitter. So here we have the Node-RED code that we had implemented for the SCADA. So these nodes are used for navigation towards the different stations. And on the second slide here, we have the nodes for station 1, which is the thermal station, where we've configured different actuators, sensors. So this station, this is the input pump, the solenoid for this PLC, configured the tags for each actuator to be read from the tier portal, also to be able to manipulate using the S7 node. Also connected the MQTT tags, whereby we can subscribe and publish data. to our MQTT server to receive information. And on the last side here is the Node-RED side for the thermal station, where we've also configured the same different sensors and the chiller and actuators for that specific station. So you can navigate to the dashboard, to the station, monitor the current temperature, the processing, also the
And now for IoT system architecture. In our communication system, we have established a robust architecture for seamless data exchange between two stations and a set of 12 volts devices, including a submersible pump and a solenoid valve. Our chosen communication protocol is MQTT, and we have employed Node-RED for data pre-processing. Our architecture centers around MQTT broker, and we have opted for an efficient and low latency mosquito broker for this crucial role. We leverage Node-RED with the S7 module to facilitate reading and writing data to and from both the analytical and the thermal station, ensuring smooth communication and data pre-processing. For a submersible pump, solenoid valve, and an ultrasonic level sensor, they are seamlessly integrated into the system through ESP Wi-Fi module. These modules connect to the rest of the network by establishing and subscribing to the MQTT broker. This setup ensures a well-coordinated and efficient communication network within our system.